Hello friends, in today's video we are going to solve some few more examples based upon the concept of conversion of solid from one shape to another. So we are going to look at three examples. So let us start with the first one. A cylindrical shaped soy wax of height 18 centimeters and radius 15 centimeters is melted and whole of the molten wax is poured into another candle mold shaped like a small cone of height 17 centimeter and radius 7 centimeter. How many such candles can be made? So here what is given to us? There is a cylindrical shaped soy wax, which here you can see its dimensions are given to us, height and radius. We have to melt this and poured into another candle mold which is shaped like a small cone, and its dimensions are also given to us. We have to find out that how many such candles of conical shape can be made from this cylindrical shaped wax. So let us look at its solution. The radius of the cylindrical wax bar is given to us. The radius is 15 centimeters and height is 18 centimeters. We have kept here capital R and capital H because both have radii and both have height also. So this is 15 centimeter and height is 18 centimeter. Now same way, the radius of the small conical candle R, which we have kept it to be small r, is 7 centimeter and the height is small h is equal to 17 centimeter. So now how do we calculate volume of a cylinder? If you can recall what is the formula, it is pi r square h, right? But because here we have considered the radius of the cylindrical wax as capital R and height as capital H, so the formula will be this one, pi r square h. Now same way, what will be the volume of a cone? The formula to calculate volume of a cone is 1 upon 3 pi r square h. Here the dimensions of cone or conical wax mold we have considered it to be small r and small h. So we have to consider this formula and not this formula, because this involves capital R and capital H, which are the dimensions of the cylindrical wax bar. But we are talking about the conical wax mold. Okay, so we have to consider this formula. So now we know about the formulas also. Here you can see that we have substituted all the values of R and H and we have calculated how much is the volume of the cylinder. Same way we will find out how much is the volume of one cone also by substituting the value of R and H. We have kept them as a multiple of pi because when we will find how many candles can be made, this pi will get cancelled. Okay, so no need to simplify by substituting the value of pi. You can just keep as a multiple of pi also. So after these values are obtained, how do we calculate the volume? For that, first of all, let us melt the cylindrical wax. Okay, so here you can see that the wax is melted. That is how it is done, right? Without melting, we cannot pour it in another mold also. So let us add some color to this. So let us add this color. Now the number of small conical candles, it will be how much? Volume of a cylinder upon volume of a cone. It will be the ratio of these volumes. Why? Because n number of cones can be calculated from the cylinder. So n multiplied by volume of one cone will be equal to volume of a cylinder. So that means number of small conical candles, it will be ratio of these two values. From here we have substituted the values. So here you can see this pi will get cancelled. So we have to divide 4050 by 277.67. First of all, let us write down the answer up to 2 decimal places. So it will be 14.59. So now let us see how many candles can be made. Will we be able to create 14.59 candles, or it will be just 14? We never create half a candle. That is why here it will be just 14 candles. Okay, so we have filled out this mold by the molten wax. Now let us see how many candles can be formed. So 14 small conical candles can be made by melting the cylindrical wax bar, which here you can see that all 14 of them Okay, so this way, whenever a question is given to you where you have to find the number of candles or number of balls that is being created by melting or by doing some procedure where the shape of the solid is changed from one shape to another, then you can always use this type of method. Okay, first of all, you should know what are the dimensions of both the shapes of both the solids, find their volumes individually, then find how many numbers or whose numbers we have to find. So it will be always the ratio of their volumes, and this is how you will be able to find. Okay, so let us look at couple more examples. Second question, a cuboidal coconut wax bar of dimensions 31 centimeter by 30 centimeter by 12 centimeter is melted and poured into another candle mold shaped like small sphere of radius 10 centimeter. How many such spherical candles can be made? Here we have to take pi is equal to 3.14. Okay, so here a wax candle is given to us, which is in the shape of a cuboidal, Now this cuboidal coconut wax bar is melted and some spherical candles are made. Now for one spherical candle, we know how much is the radius of it. We need to find out how many such spherical candles can be made. So how are we going to do it? We are going to find the volume of the cuboidal wax bar. We will find volume of one spherical candle, and then we will divide both the values to find the number of spherical candles that can be made. So here length is given to us 31 centimeters of the cuboidal wax bar. Breadth it is 30 centimeters and height it is 12 centimeters. Okay. Now the radius of the small spherical candle, it is given to us 10 centimeters. We have substituted all the values. Let us look at the formula. So now how do we calculate volume of a cuboid? It is simple. L times B into H, right? So this is the formula. Let us substitute the values and find the volume of the cuboid. So this is the value that we will get by multiplying 31 times 30 times 12. Okay, now same way let us find out what is the volume of a sphere. Now what is the formula to calculate the volume of a sphere? It is 4 upon 3 pi r cube. We already know what is the value of r. Substitute the value of r. And here we have substituted the value of pi. In the previous example, we did not, because both the volumes had the value of pi involved. Here there is no value of pi involved in the volume of cuboid. That is why here we will substitute the value of pi and then we will find the volume of sphere. So we got both the values. Now to find the number of candles, we will first of all melt the cuboidal coconut wax bar. So now it is getting melted. Okay, the cuboidal coconut wax bar. Now let us add some color to it. So now let us find out the number of small spherical candles. It will be the ratio of these two values. Okay, the formulas are written, the values we have already calculated it out. So let us find out this value and we have to keep it up to 2 decimal places. It will be 2.67. So that means how many spherical candles can be made out of this cuboidal coconut wax bar? Only 2 candles, because we cannot consider this 0.67, right? So only 2 spherical candles can be made when we melt this cuboidal coconut wax bar of this given dimensions. Okay, now let us look at another type of question where we have to find the missing dimension of one of the solids. A spherical ball shaped honeybee wax of radius 10 centimeter is melted and poured into another candle mold of cylindrical shape with radius 7 centimeters. Find the height of the cylindrical candle. So what is given to us here? So spherical ball shaped honeybee wax is already given to us of radius 10 centimeter. Now this is melted. It is poured into this mold of cylindrical shape with radius 7 centimeters. But we do not know the height. Remember, the height of the mold is not important here. But after melting this spherical ball, what will be the height of the candle? That is what we have to calculate. Okay, that is why here in the question it is given to us. find the height of the cylindrical candle, not cylindrical mold. So understand the difference. Okay. So again, same way, first of all, let us write the dimensions of both the solids. So the radius of the spherical ball shaped wax, it is given to us 10 centimeters. Now let the height of the cylindrical mold be 8 centimeters. That is the value we have to calculate. The radius of the cylindrical mold is capital R. Why capital R? Because there are two R's involved. Either you can write down R1, R2, or you can use capital R and small r. Okay. So here for the cylindrical mold, the radius is 7 centimeters. So now how do we calculate volume of a sphere? It will be 4 upon 3 pi r cube. Now here we have the value of r. So that is what we are going to substitute and find the value. Okay, we have kept this as a multiple of pi because in the volume of a cylinder also pi is involved. So pi will get cancelled. Okay, so now volume of a cylinder, it is calculated by pi r square h. But here the dimensions of the cylindrical mold are capital H and capital R. That means the formula should also have capital R and capital H. So it will be this formula, pi r square h. So again, we have the values of R. So let us substitute it out. Now here we do not know what is the value of H. So that is why this is in the form of pi H. So we have both the values of the volumes. Now we have to find the height. So first of all, we are going to melt this spherical ball shaped honeybee wax. Add some color and we will pour it in the mold. So let us add this pink color here. So now let us pour it in the mold wax. So we have poured it. Now here clearly you can see that when we poured the wax in the mold, the height of the candle and the height of the mold do not match. That is why in the starting of this question I said we need to find the height of the cylindrical candle and not of the mold because they may not match here. Okay, so now how do we find the height of the cylindrical candle? It will be volume of the spherical ball shaped wax will be equal to volume of the cylindrical candle. So that means these two formulas will be equal. We know what are the values, what is the simplification of both the sides. So H will be ratio of these two values, which will be something like this. Okay, so the value of H, which is the height of the cylindrical candle, it will be 27.21. So that is the height of the cylindrical candle. Okay, so this is how we can solve questions based upon the concept of conversion of solid from one shape to another. And this is something that is done whenever candles are made or whenever even spherical balls are created or whenever a well is dug and then the soil is shifted into another shape. So in all of these, conversion of solid from one shape to another is applied. So even though when we look at such scenarios in our day-to-day life, we do not relate it that here such type of mathematics is involved. But now I hope you can relate to it. Okay, so I hope you were able to understand all of these three examples. Thank you so much.